Welcome to another cool math video. My name is Ali. Today, I want to talk about a technique that I absolutely love. It helps you find average problems in various settings. I call it the fat guy on the seesaw method. Yes, you heard it right. How can you use a fat guy on a seesaw to solve average problems? Isn't that wonderful? So, the way a seesaw works is two people, right, stand on both sides, and then there's a fulcrum, the balance point in the middle somewhere. But that point depends on, if it's on balance, that point depends on the weights and the distances. So the weight here times the distance to the balance should be the same as the weight here times the distance to the balance. So, and then the balance point, the fulcrum, can be thought of as the new average of those fat guys, right? And then if you have one times fat guy here, one times fat guy here, then you can imagine in the new setting, if you take out those fat guys and put a fat guy that's two times fat in the fulcrum at the same point as the fulcrum, then that's the same setting. So you can replace the same way as if you have like numbers 1, 2, 3, 4, 5. For average purposes, the average is at 3, right? And the same with 5 threes, 3, 3, 3, 3, 3, the average is also 3. They have the same sum, the same average. So we can replace them with a fatter guy at the fulcrum point. So that's the idea. Let's see it in action in this problem, a problem from past AMC 10. We have a list of numbers, and then we add 15, the mean increases by 2. Then we add 1, the mean this time decreases by 1. How many integers were there in the original list? So there are two unknowns here. We don't know how many numbers in the original list, and we don't know what their original average was, right? So in the regular solution, you can write two equations, one equation for each of the sentences given, and there will be two equations, linear equations with two unknowns. You can solve them to find, well, actually, they won't be linear, right? We will have n times k somewhere. So two equations with two unknowns, you need to solve them somehow. So let's try to see how the fat guy on the seesaw method might work on this. So I'm gonna write n numbers here. We don't know how many for the original list. So we are trying to find what is n. Now I'm gonna imagine a seesaw here, and we don't know what the original average is, but we know that the new guy, the new fat guy added, is at 15. So this is one number, so 1 times fat. And then somewhere here, there's a fatter guy, n times fat. And I don't know where that guy is. That's the average of the original n numbers. And these guys balance. So the mean is increased by 2. So from question mark, we get to a point, let's say here. Right? The distance from the original list of fat guys to the fulcrum point is 2. Now, the weight times distance equals weight times distance on both sides. So 2 times n equals 1 times 2n. So this distance should be 2n. And then in the new setting, so you can imagine a fatter guy here whose fatness is n plus 1, n plus 1 times fat. Here we have an even fatter guy, n plus 1 times fat. And then when we add a new number, just regular fat guy at 1, the mean decreases by 1 this time. So the distance here is 1. Now the same fact, weight times distance equals weight times distance on both sides. N plus 1 times 1 equals 1 times n plus 1. So this distance on the left to the fulcrum point should be n plus 1. All right, so how do we find n from these? The nice thing here is that we had two unknowns, but we are basically only working with one unknown here, n. There's this question mark where n is located, the n times fat guy is located, is also an unknown, but we can just kind of hide it. We don't need to work with it. We just need to find the distance from 1 to 15, right? So 15 minus 1 equals, so how do you go from 1 to 15? First, we go from 1 to this point, and then another 1 to get to this point. And then from here to 15, we have another 2n. n plus 1 plus 1 plus 2n. That gives us 3n plus 2 equals 14, 3n equals 12, and n equals 4. So there were 4 numbers in the original list. You can use this in so many different average problems. So whenever you come into a somewhat challenging average problem, try this method, fat guy on the seesaw method. Fat guy on the seesaw, that's your friend. All right, I hope you enjoyed it. For more cool videos like this, please subscribe. Thank you. Doot, doot, doot.